Section 1 of Natural Science and Religion. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Natural Science and Religion by Asa Gray. Lecture 1, Scientific Beliefs. Part 1. I am invited to address you upon the relations of science to religion, in reference, as I suppose, to those claims of natural science which have been thought to be antagonistic to supernatural religion, and to those assumptions connected with the Christian faith, which scientific men in our day are disposed to question or to reject. While listening weekly, I hope with edification, to the sermons which it is my privilege and duty to hear, it has now and then occurred to me that it might be well if an occasional discourse could be addressed from the pews to the pulpit. But until your invitation reached me, I had no idea that I should ever be called upon to put this passing thought into practice. I'm sufficiently convinced already that the members of a profession know their own calling better than anyone else can know it, and in respect to the debatable land which lies along the borders of theology and natural science, and which has been harried by many a raid from both sides, I am not confident that I can be helpful in composing strifes or in the fixing of boundaries, nor that you will agree with me that some of the encounters were inevitable and some of the alarm groundless. Indeed, upon much that I may have to say, I expect rather the charitable judgment than the full assent of those whose approbation I could most wish to win. But I take it for granted that you do not wish to hear an echo from the pulpit nor from the theological classroom. You ask a layman to speak from this desk because you would have a layman's thoughts, expressed from a layman's point of view, because you would know what a naturalist comes to think upon matters of common interest, and you would have him liberate his mind frankly, unconventionally, and with as little as may be of the technicalities of our several professions. Frankness is always commendable, but outspokenness upon delicate and unsettled problems, in the ground of which cherished convictions are rooted, ought to be tempered with consideration. Now I, as a layman, may claim a certain license in this regard, and any overfree handling of sensitive themes should compromise no one but myself. As a student who has devoted an ordinary lifetime to one branch of natural history, in which he is supposed to have accumulated a fair amount of particular experience, and to have gained a general acquaintance with scientific methods and aims, as one, moreover, who has taken kindly to the new turn of biological study in these latter years, but is free from partisanship, I am asked to confer with other and younger students of another kind of science in respect to the tendencies of certain recently developed doctrines, which in schools of theology are almost everywhere spoken against, but which are everywhere permeating the lay mind, whether for good or for evil, and are raising questions more or less perplexing to all of us. But our younger and middle-aged men must not think that such perplexities and antagonisms have only recently begun. Some of them are very old. Some are old questions transferred to new ground, in which they spring to rankness of growth or sink their roots till they touch deeper issues than before. Issues of philosophy rather than of science, upon which the momentous question of theism or non-theism eventually turns. Some, on the other hand, are mere survivals, now troublesome only to those who are holding fast to theological positions which the advance of actual knowledge has rendered untenable, but which they do not well know how to abandon, yet which, in principle, have mostly been abandoned already. To begin with trite examples, among the questions which disquieted pious souls in my younger days, but which have ceased to disquiet any of us, are those respecting the age and gradual development of the earth and of the solar system, which came in with geology and modern astronomy. I remember the time when it was a mooted question whether geology and orthodox Christianity were compatible, and I suppose that when in these quarters the balance inclined to the affirmative, it was owing quite as much to Professor Silliman's transparent Christian character as to his scientific ability. One need not be an old man to know that Laplace was accounted an atheist because he developed the nebular hypothesis, and because of his remark that he had no need to postulate a creator for the mathematical discussion of a physical theorem. For a venerable and most religious astronomer still living, who adopted this hypothesis in his Exposition of Certain Harmonies of the Solar System, published only 5 years ago, thought it needful to add an appendix asking the question, is the nebular hypothesis in any form essentially atheistical in its character? He answered it in the negative, but with the salvo that, quote, this hypothesis having to do with a strictly azoic period enforces no connection with the development theory of the beginning or of the progress of life, close quote. The great antiquity of the habitable world and of existing races was the next question. It gave some anxiety 50 years ago, but is now, I suppose, generally acquiesced in the sense that existing species of plants and animals have been in existence for many thousands of years, and as to their associate, man, all agree that the length of his occupation is not at all measured by the generations of the biblical chronology, and are awaiting the result of an open discussion as to whether the earliest known traces of his presence are in quaternary or in the latest tertiary deposits. As connected with this class of questions, many of us remember the time when schemes for reconciling Genesis with geology had an importance in the churches, and among thoughtful people, which few, if any, would now assign to them. When it was thought necessary, for only necessity could justify it, to bring the details of the two into agreement by extraneous suppositions and forced constructions of language, such as would now offend our critical and sometimes our moral sense. The change of view which we have witnessed amounts to this. Our predecessors implicitly held that Holy Scripture must somehow truly teach such natural science as it had occasion to refer to, or at least could never contradict it, while the most that is now intelligently claimed is that the teachings of the two, properly understood, are not incompatible. We may take it to be the accepted idea that the Mosaic books were not handed down to us for our instruction in scientific knowledge, and that it is our duty to ground our scientific beliefs upon observation and inference, unmixed with considerations of a different order. Then, when fundamental principles of the cosmogony in Genesis are found to coincide with established facts and probable inferences, the coincidence has its value, and wherever the particulars are incongruous, the discrepancy does not distress us, I may add, does not concern us. I trust that the veneration rightly due to the Old Testament is not impaired by the ascertaining that the Mosaic is not an original but a compiled cosmogony. Its glory is that while its materials were the earlier property of the race, they were in this record purged of polytheism and nature worship, and impregnated with ideas which we suppose the world will never outgrow. For its fundamental note is the declaration of one God, maker of heaven and earth, and of all things visible and invisible, a declaration which, if physical science is unable to establish, it is equally unable to overthrow. But leaving aside for the present all questions of this sort, I proceed with the proper subject of this discourse, namely, the further changes in scientific belief which have occurred within my own recollection ever since the time when I first aspired to authorship, now 45 years ago. There will be no need to go much beyond the line of subjects which it has been my business to study in order to bring before you in a cursory review not indeed all the disturbing topics of the time, but quite enough of them for our purpose. For the changes which we have to consider are all more or less connected with the evolutionary theories which are now uppermost in the popular mind. In this presentation, it is best to set them forth in their simplest or most general form, divested of all theological or philosophical considerations which have been or may be attached to them. I should rather say, to some of them, for the foundations, or at least the buttresses, of the now prevalent doctrine of the derivative origin of species mainly rest upon researches independently made without speculative bias, being the general contributions to biological science in this century, the results of which have been accepted as far as made out without apprehension or other than scientific controversy. Upon no one of these particular points has there been a completer change of view than upon the distinctness of the animal and vegetable kingdoms. The former conviction that these two kingdoms were wholly different in structure, in function, and in kind of life was not seriously disturbed by the difficulties which the naturalist encountered when he undertook to define them. It was always understood that plants and animals, though completely contrasted in their higher representatives, approached each other very closely in their lower and simpler forms, but they were believed not to blend. It was implicitly supposed that every living thing was distinctively plant or animal, that there were real and profound differences between the two, if only they could be seized, and that increased powers of investigation, microscopical and chemical, might be expected to discover them. This expectation has not been fulfilled. It is true that the ambiguities of 100 years ago are settled now. The zoophytes are all remanded to their proper places, though the animal kingdom at first claimed more than belonged to it. But other, more recondite and insurmountable difficulties arose in their place. The best, I am disposed to say the settled, opinion now is that there are multitudinous forms which are not sufficiently differentiated to be distinctively either plant or animal, while as respects ordinary plants and animals, the difficulty of laying down a definition has become far greater than ever before. In short, the animal and vegetable lines, diverging widely above, join below in a loop. Naturalists may help classification, but do not alter these facts when they sever this loop arbitrarily at what they deem the lowest point, or when they cut away the whole loop and form of it a separate kingdom, the Protista of Haeckel. The only objection to the latter is that the definition of this tertium quid from plant on the one hand and animal on the other is equally impracticable. One difficulty is removed only to have two in its place. The fact is that a new article has recently been added to the scientific creed, the essential oneness of the two kingdoms of organic nature. I crave your patience while I enter somewhat into particulars. Not many years ago, it was taught that plants and animals were composed of different materials. Plants, of a chemical substance of 3 elements, carbon, hydrogen, and oxygen. Animals, of one of 4 elements, nitrogen being added to the other 3. The plant substance, named cellulose because it formed the cell walls, was supposed to constitute the whole vegetable fabric. It was known that all plants produced nitrogenous matter in the form of a compound of 4 elements, but this was thought to be merely a contained product in a structureless condition, and to be not so much essential to the plant's life as to that of the animals which the plants nourished. It was known to be structure-building material for animals. It was not known to be essential plant structure also. But it was soon ascertained that this quaternary matter of the animal body was chemically the same in the plant, was elaborated there, and only appropriated by the animal. Next, it was found that it was physiologically and structurally the same in the plant, that it was the living part of the plant, that which manifested the life and did the work in vegetable as well as in animal organisms. This substance, which is manifold in its forms and protean in its transformations, has in its state of living matter one physiological name which has become familiar, that of protoplasm. The statement that protoplasm is the physical basis of life must be accepted as true. As Professor Allman puts it, quote, "Wherever there is life, from its lowest to its highest manifestations, there is protoplasm. Wherever there is protoplasm, there too is life," close quote, or has been. The cellulose or solid material which composes the bulk of a tree or herb did not produce the protoplasm contained in its living parts as was formerly supposed, but the protoplasm produced the cellulose. The semi-liquid and mobile matter within produced the cell walls which enclose it. The walls or solid parts are to the protoplasm what the shell is to the oyster. The contents not only preceded the protective investment, but can exist and prosper apart from it, as many a mollusk does, as many a simple plant does throughout the earlier and most active period of its life. Indeed, this slimy matter lives before and apart from anything which can be called a living being. A formless, apparently diffluent and structureless mass is seen to exhibit the essential phenomena of life, to move, to feed, to grow, to multiply. We have spoken of beings so low in the scale that the individuals throughout their whole existence are not sufficiently specialized to be distinctively plant or animal. Yet these are definite in form and fixed in phase, are individual beings, though we may not determine to which kingdom they belong. But there is life in simpler shape, quote, "If shape it might be called, that shape has none, distinguishable in member, joint, or limb," close quote. There is vital activity in that which has not attained even the semblance of individuality. Little lumps of protoplasm are these, with outline in a state of perpetual change, divisible into 2 or 3 or more, or 2 or 3 combining into one mass, either way without hindering or altering their manifestations. This living matter, of which Bathybius, if there be a Bathybius, or if it be anything more than protoplasm of sponges, is one example, is said to have nothing more than molecular structure. It would be safer to say that the microscope has as yet revealed no organic structure. The natural history of protoplasm has recently been well expounded by Professor Allman, late president of the British Association, a most judicious naturalist of conservative tendency, and his address, which you have read or should read, saves me from further details and enables me to proceed to other evidences of the substantial oneness of the two kingdoms of organic nature. Cellulose makes up the bulk of a vegetable, and was thought to be its true element, but it is now known to be not even peculiar to it. It enters largely into the fabric of certain animals, not of the very lowest grade. Starch was equally regarded as a purely and characteristically vegetable production, and its presence, in ambiguous cases, has been taken as a test. But it follows the example of cellulose. Being a prepared material from which cellulose in the plant is made by a molecular change, we are not now surprised to learn that starch grains of animal origin have been found. We cannot conceive anything more characteristic of a vegetable than chlorophyll, the green of herbage, for in it the special work of the plant is done, namely the transformation of mineral matter into organic under the light of the sun, this being the prerogative of vegetation. Now, not only does chlorophyll abound in many ambiguous microscopical organisms of fresh and salt water, which except for this would be taken for animals, but it has recently been detected in hydras and sea anemones and planarias, which are as certainly animals as are oysters and clams. Nor can it be thought that they possess something merely resembling chlorophyll, for it performs the characteristic work of that peculiar substance which, as I have said, is the characteristic work of vegetation. For the index and essential accompaniment of this work, i.e. of the conversion of mineral into organic matter, is the evolution of oxygen gas from the decomposition of carbonic acid, water, etc., in which, if in anything, vegetation consists. Now the proof that what these animals possess is chlorophyll itself is demonstrated by their performance of the same function. They decompose carbonic acid and evolve oxygen gas, just as a green leaf does. Moreover, the chlorophyll has been extracted and identified by the spectroscopic test. Here, then, animals, undoubted animals, in addition to their own proper functions, take on the essential function of plants. There is no avoiding the conclusion that such animals are doing the duty of vegetables. Although I make little account of it, I should not overlook a more empirical distinction between the two kingdoms which has also failed. The characteristic features of an animal were mouth and stomach. This is the normal correlation of an animal with its conditions. Having to feed on vegetable matter, or what has been vegetable matter, in solid as well as liquid form, a mouth opening into an internal cavity of some sort was the natural pattern to which all animals were supposed to conform. But nature, with all her fondness for patterns, will not be arbitrarily held to them. Entozoa feed like rhizophytes, and turbellarias and their relatives have no alimentary canal, the food taken by what answers to mouth passing as directly into the general tissue as does the material which a parasitic root imbibes from its host, or an ordinary root from the soil. While animals are thus overpassing the boundary in one direction, vegetables are making reprisals on the other. The rule is that vegetables create organic matter, and animals consume it, producing none. But while some animals produce some organic matter, some plants, even among those of the highest grade, feed wholly upon other plants, or even upon animals or their products. Like animals, some are herbivorous and some are carnivorous. That certain plants live parasitically upon other plants or upon animals has long been too familiar to be remarkable. But that plants of the highest grade could capture or in some way take possession of small animals, extract and feed upon their juices, and appropriate these as nourishment, is essentially a recent wonder and a recently ascertained fact. Yet some of the facts which point to this conclusion are old enough, and the conclusion would probably have been reached years ago, except for the preconception that plants and animals were too distinct for interchange of functions. Now that we know they are not, and that the living structure in the two is fundamentally identical, what were formerly regarded as freaks of nature are no longer mere wonderments, but parts of a system, and capable of being correlated with the rest by investigation. And investigation soon ascertained that this carnivorous attachment to the vegetable organism in Dionaea and Drosera was an organ for digesting as well as capturing animal food. Juices are imbibed by it directly, as in animals from the stomach, and nourishing solid parts are rendered soluble and assimilable by imbuing them with peptones or digestive ferments, analogous in composition and in action to the gastric juice of the higher animals. Perhaps nothing in nature can be more wonderful than all this, and nothing is more characteristic of the change which has come over scientific mind in our day than the manner in which such a discovery is received. The leading facts were well known 100 years ago, and more, but until recently these phenomena were regarded as altogether anomalous, and such anomalies appear to have troubled nobody except the framers of definitions. Lusus naturae was a convenient phrase, and stood in the place of explanation, as if the play of nature was something apart from her work. No one seems to have had any difficulty in believing that a few particular plants were endowed with faculties of which no other plants were sharers. The thoughtful naturalist of our day is in a different frame of mind. He expects to find that the extraordinary is only an extreme case of the ordinary, and he looks for instances leading up from the one to the other. I cannot tarry to explain how this expectation has directed observation and stimulated research in this particular field, and reached the result that these wonderful plants are distinguished only by higher degrees and more prominent manifestations of a power which is in some sort common to many or to all their brethren. We learn even that the germinating embryo of a grain of corn feeds upon and digests the solid maternal nourishment which surrounds it, and the humblest mold appropriates the organic matter which it attacks by the aid of a peptone or inversive ferment, not different in nature and office from the gastric and other juices by aid of which we appropriate our daily meals. It does appear also that the lowest organisms, which live a kind of scavenger life by using over again dead or effete organic matter running to decay, but to some of which living juices come not amiss, have also the power, certain salts being given, of creating organic matter and building up a fabric without sunlight and without chlorophyll. Here then is the simplest organic life, in which, germs being given, i.e. first individuals of the sort supplied and placed in favorable surroundings, they increase and multiply into more, each to multiply again, and so on in geometrical progression. From such lowly basis the two kingdoms may be conceived to rise, diverging as they ascend in separate lines, the one developing close relations with sunlight and becoming the food-producing vegetable realm, the other the food-consuming animal realm, which, dispensed from the labor of assimilation and from the fixity of position which generally attends it, may rise to higher and freer manifestations of life. Such, at least, appear to be the relations of the two kingdoms to each other and to their common base, and such is the conception through which we may attain to an explanation of how it may be that members of each line possess so many characteristics of the other. I have said, germs being given, the forms increase and multiply. If asked, whence the germs, and were they everywhere and always prerequisite, the scientific answer must be yes, so far as we know. Thus far, spontaneous generation, or abiogenesis, the incoming of life apart from that which is living, is not supported by any unequivocal evidence, though not a little may be said in its favor. However it may be in the future, here scientific belief stands mainly where it did 45 years ago, only on a better tried and firmer footing. It remains to mention two supposed distinctions between vegetables and animals, which were until recently prominent, but which are no longer criteria, even as between the higher forms of the two. The first is the faculty of automatic movement, or, to take up the question only on the highest plane, the faculty of making movements in reference to ends. This is affirmed of animals, and is an undoubted faculty of all of them, but was long denied to plants, perhaps from a notion that such movements argued consciousness. But consciousness, in any legitimate sense of the term, pertains only to the higher animals. To show the breaking down of the distinction, it would suffice to contrast the rooted fixity and vegetative growth of very many lower animals with the free locomotion of most microscopic aquatic plants and of the germs of those not microscopic. But plants of the highest organization furnish obvious examples better suited to our purpose. Is there not an independent movement in response to an external impression and in reference to an end when the two sides of the trap of Dionea suddenly enclose an alighted fly, cross their fringe of marginal bristles over the only avenue of escape, remain quiescent in this position long enough to give a small fly full opportunity to crawl out, soon open if this happens, but after due interval shut down firmly upon one of greater size which cannot get out, then pour out digestive juices and in due time reabsorb the whole? So, when the free end of a twining stem or the whole length of a tendril outreaches horizontally and makes circular sweeps and secures thereby a support to which it clings by coiling, when a tendril, having fixed its tip to a distant support, shortens itself by coiling, so bringing the next tendril nearer the support, when a free revolving tendril avoids winding up itself uselessly around the stem it belongs to, and in the only practicable way, namely, by changing from the horizontal to the vertical position until it passes by it and then rapidly resumes its horizontal sweep to result in reaching a distant support. Is it possible to think that these are not movements in reference to ends? You may say that all such movements are capable of explanation, or in time will be so, are the result of mechanism and adjustments and of common physical forces. No doubt, and this is equally true of every animal movement, not excepting those instigated by volition. Still it moves, as the humbled Galileo said of the earth, and the idea that such movements are in reference to ends is not superseded by any yet devised explanation of the mechanism. Our remaining distinction between plants and animals was based on the relations they respectively sustain to the air we breathe. This has already been stated and the exceptions noted, but the topic is resumed in order to bring to view the substantially different relations of the two kingdoms to physical force. Plants give out oxygen gas and thus purify the air for the respiration of animals. Animals consuming this oxygen breathe it back to the air in the form of carbonic acid. But the putting of this contrast is only another way of saying that plants produce organic matter and animals decompose it. The oxygen gas given out by sunlit foliage is just what is left over when carbonic acid is decomposed and the carbon enters into the composition of the vegetable matter then produced. This elaborated matter, more complex and unstable than the materials of which it was made, is the food of animals, is first appropriated, then decomposed by them, and in the decomposition the carbon is given back to the air, recombined with the oxygen they inhale, the carbon again taking the oxygen which was separated from it by the plant. So, respiration means decomposition. And this decomposition in the animal economy means organic material used up, work done, energy degraded. It means that the clock weight which was wound up by the sun in the plant has run down. It means that, very much as the sun shining on the earth and ocean converts water into vapor and lifts it into the upper air, so the same luminary, shining upon the plant, there raises mineral matter to a higher and unstable state in what we call organic products, in both cases endowing the affected matter with a certain energy. The exalted matter in the one case falls at length as rain, perhaps directly into the ocean from which it was lifted, perhaps upon a mountain summit, where as snow or glacier ice it may long remain poised and comparatively stationary. But sooner or later it falls into the rivulet and the river, and in its fall and flow it expends its endowment of energy and does work, turns wheels and spins or forges if man so directs. And when it has reached stable equilibrium at the level of the ocean, it will have expended just the energy which was imparted to it in the raising. So the energy with which the sun endowed vegetable matter when it was raised to the organic state may be given up as heat when this matter is restored to its original condition by burning, or falls slowly back to the same condition in the process of natural decay, or the heat, like the falling water, may do mechanical work. But also, the organic material may be consumed in the plant itself, for the plant, like the animal, is a consumer. The only difference is that, whereas the animal is always and only a consumer and decomposer, the plant creates or composes likewise, and it produces vastly more than it consumes or decomposes. It decomposes only when it does mechanical work. But all its processes, all movements, all transformations are work done at the expense of organized material and accumulated energy. Even the act of storing up solar force in the green herbage, or rather the changes connected with it, can only be done at a certain cost, though the cost is small in comparison with the gain. But every transference of material from one place or one state to another is done only by the decomposition and loss of some portion of it, one part suffering that another may be changed and saved. When the germ feeds upon the maternal store in the seed, a considerable part is consumed in order to make the rest available, and the loss is made manifest, just as in the breathing of an animal or in the combustion of fuel, by the evolution of carbonic acid and of heat. The same thing, in its measure, occurs in the upbuilding of the fabric, the carrying of material high into the air, into a treetop for instance, and in all the processes of flowering, and in storing up in the seed the richest products as an outfit for a new generation. Where visible movements take place, the quicker action is at equivalent cost. The sensitive tendril, which will coil promptly after the first brushing with my finger, will coil again only after an interval of rest, and upon the third or fourth excitation, or after a certain number of spontaneous revolutions, it falls exhausted. But material endowed with energy in the plant is largely transferred as food to animals. It brings to them an energy which they may use but did not originate. Not many years ago, it was taken for granted that living things moved and had their being and did their work by strength of their own, that the power by which I strike a blow, or write on my paper, or move my lips in articulate speech, was somehow an original contribution to, rather than a directed use of, the common forces of physical nature. To all who have familiarized themselves with the facts of the case, the contrary is now substantially certain. The sun is the source of all motion and force manifested in life on the earth, and plants are the medium in which energy is exalted to the most serviceable state. The work done by living beings is at the expense of, and is measured by, the passage of so much matter from an unstable to a relatively stable equilibrium by the coming together of molecules into closer and firmer positions, and by the attendant fall of so much energy from an exalted to a relatively degraded condition. So plants, animals, men, in all their doings, add nothing to and take nothing from the sum of physical force. Their prerogative is, each in its measure, to direct the application of physical force and to direct it to ends.